So in this video, we will discuss how to generate a single sideband signal using the phase shift method. Um in a previous video, we have seen that the expression, the mathematical expression for the single sideband signal involves the Hilbert transform. So what is a Hilbert transform? So for a signal xt, the Hilbert transform xhf, in the Fourier domain or in the frequency domain, is equal to minus j x of f, which is the Fourier transform of xt, and sine of f. Now, from this definition, this means that if there is a signal mt and it passes through the transfer function hf, which is equal to minus j sine of f. So this minus j and sine of f, if our signal mt passes through this transfer function, as a result at the output we will get the Hilbert transform mht, so which is the Hilbert transform of mt. Now if we write this hf, write the expression of this hf, it's equal to minus j sine of f, which means that it's equal to minus j for positive frequencies, means positive values of f, and it's equal to j for the negative values of f. So from this expression it follows that the magnitude of hf is equal to 1, so it does not introduce any change in the amplitude or the magnitude of the signal, that is the mt, but it changes the phase of the signal by minus pi by 2 for the positive frequencies and by pi by 2 for the negative frequencies. So that means if we change the phase of every component of mt by minus pi by 2 without changing its amplitude, of course, and the resulting signal would be mht. So if we start from this point, if we consider only the positive frequencies, so if we change the phase of mt by minus pi by 2, so that will be equivalent to getting the Hilbert transform of mt, which is represented by mht. So in summary, a Hilbert transformer is an ideal phase shifter that shifts the phase of every component by minus pi by 2, right? So the magnitude remains the same if we pass a signal through a Hilbert transformer, but the phase shift is represented by this this plot. So from this it means that if we can change the phase of the signal, the message signal, then we can get the single sideband modulated signal. So that's why this technique is called the phase shift method. Now the expression for the general expression for a single sideband modulation is shown here, where we are we have the mt cos omega ct, and then we have mh t, which is the Hilbert transform of mt, and sine omega ct. So these two terms are phase shifted as compared to these two terms. So this is the general expression for a single sideband modulated signal. Now a phase shifter, in this technique, the phase shift method, a phase shifter is used to vary the phase of every positive spectral component by minus pi by 2. So that would mean that we are performing the Hilbert transform function. Now Hilbert phase shifter requires an abrupt change of pi at zero frequency. So as we observed in the previous slide, there is an abrupt change, a total change of pi at zero frequency. So ideal Hilbert transform is not realizable. And so we will have an approximate phase shift, an approximate Hilbert transformer. So when the message signal empty, but that's not a very a big issue if the message signal mt has DC null or very low frequency content around the zero frequency. So if this message signal has very low frequency content around the zero frequency, then even an approximate Hilbert transformer can perform very well. So this is the implementation of the phase shift method. So effectively this block diagram implements the expression that we saw on the previous slide. So MT, the input message signal, is split into two paths. In both the paths we have a double sideband suppressed carrier modulator. So this is a simple AM modulator that we have discussed in other videos. So in one of the path there is a phase shifter of minus pi by 2. That's in order to get the Hilbert transform of the signal MT. And then we also have at the input a sinusoidal carrier, so which is represented by cos omega ct. Now as we saw in the expression that with mht we have the carrier that multiplies is sine omega ct, so that's why this sign is shifted by an amount of pi by 2 from the cos, so that's why we have a phase shifter in the path between this point and the double sideband suppressed carrier modulator. So the input of this DSB SC modulator is cos omega ct and mt, and the input of this DSB SC modulator is the Hilbert transform of MT, which is MHT, and the other input is sine omega CT. So at the output we obtain the amplitude modulated signals, which is the product of these two inputs, and when we combine them or subtract them or add them, we will get a single sideband modulated signal at the output. So this was the discussion on the phase shift method of generating single sideband modulated signal. If you have any queries, please feel free to send in the message or in the comments, and don't forget to subscribe to the channel. Thank you.